Good morning, everyone. Thanks for joining us today for the STEM, Science, Technology, Engineering, and Mathematics Career Expo session. This morning, I want to introduce to you our two presenters. So we have Dennis Yanda from Broadwind and Austin Van Steenberg from Emerging Technology LLC. So I will let them get started and do a little bit more of an introduction, and we'll go from there. Thanks.
All right. So who's Austin, do you want to go first or do you want me to go first?
I'm standing in for Mark today, so why don't you go first and I'll follow suit. All
right, so let me see if I get this right. We always use Teams, we don't use Zoom, so I'm not a Zoom person here. All right, so you guys see the screen here?
Yes, Dennis, if you can put it in presentation mode, that would be great.
Yeah, that's what I'm trying to do. Does that work? It's in presentation mode in PowerPoint, but I don't think that's showing what you want to show.
Nope, that's all right though. Just go ahead. We can still see it. So.
All right. Okay. Yeah, like I said, I'm not a Zoom expert. We use Teams here at Broadwind, so I use that pretty well, but Zoom I'm not. So I got about what 15 minutes, as I recall.
Yes.
Okay. So don't be shy about telling me to move on if I take too long. If it looks like I'm going too slow. I've got about 16 or 17 slides. So what I'm going to talk about this morning is engineering, of course. And the first slide here is just an emphasis that engineers really do make a difference in the world. And the photograph there kind of helps explain that just a little bit. So the next slide, however, is just a little comic here, which I get a kick out of. You know, when you think about what would the world be without engineers? Well, everybody's got an imagination, right? So it's hard to say what it might be like if we didn't have a lot of the engineering technology that we've come accustomed to. But chances are it wouldn't be near as nice or convenient as it is today without engineers. And if you think about it a little bit more, if you think about the impact that engineers have had on the world and our living, our lifestyle, the conveniences we have, you see the list there. It's a very, very long list, but some of the things that we're most accustomed to today that we just totally take for granted, things like cell phones, video games, MP3 players, or your iPhone or your Android phone, and the music you can play on them, the internet, televisions, you name it. All those things are a consequence of the development of technology that has then in turn been applied to practical applications that we use today. And I want to make that distinction for you. When we talk about technology, you have the application of technology in products or in equipment, that the equipment being machines that do things, or products for end users, consumers. So that's the application of technology, which is really the primary focus of engineers. But then there's also the development of technology. And that's what we oftentimes think of as a scientist. But you can be involved in the development of new technology as an engineer, just as well as in the application of technology. And I want to make that distinction because that actually broadens the horizon even further in terms of the opportunities you might consider in a career.
Dennis, Dennis, sorry to interrupt, but you're on the first slide yet for us.
You're kidding me.
There we go. Second.
Wow. Okay. Sorry, but well, thank you for bringing that up. This was the second slide. I don't know why it's not showing on this screen, this other screen, but this is the second slide that I had been talking about. I was just kind of joking around. What would the world be like? What would life be like without engineers? Use your imagination, right? This is the slide I was on. I apologize for that. talking about the various things that engineering has brought to fruition for us in the lives that we live today versus say 100 years ago or 200 years ago. And I was making the point about making a distinction between the application of technology versus the development of technology. And engineers can be involved in either of those areas. And I think that's a very important distinction to make. And within those two areas, the application or the development of technology, there's a lot of different disciplines within engineering. And I think this is also a very important point to understand, because if you're thinking, yeah, I kind of think I like math and I kind of like problem solving, things like that, but what do I do with that? Within engineering, there are a lot of different disciplines, and you see mechanical, there's electrical, there's electronic, industrial. There's a lot of different disciplines within engineering to specialize in. Kind of like when you think of going to the doctor, you have a general practitioner, but then you also might have someone who's specializes in the cardiovascular system, or in lymph nodes, or in the brain, or whatever. A lot of different specializations. The same is true in engineering. So you don't have to restrict yourself in your thinking. Start thinking, very broad, and narrow it down to what you think might really appeal to you and have a passion for. Not only are there a lot of different disciplines within engineering, there's an awful lot of different industries that you can become involved in. And I guess in some respects, I could be a poster child for that, because in my career, I've been involved in the shipbuilding industry, in the automation equipment industry, factory automation, in heavy equipment, mobile equipment, in the air conditioning industry, and that's all in the application of technology. But I've also been involved in my career in the development of technology. And that's been somewhat, we kind of call it sometimes bleeding edge development. You're really on the leading edge of developing new technology in superconductivity, in electromagnetics, material synthesis. It's been superconductivity. Those are all areas I've been involved in research. So the point I'm trying to make is, within engineering, there's this huge sphere of both technologies, disciplines, and industries that you can have a career in. And because of the fundamental nature of engineering education, the basics of what you learn in terms of problem solving, the application of those kinds of skills allow you to be very, very versatile. So you could start your career in one area and end your career doing something totally different, and all stay within engineering because you have the fundamentals, that basic education of engineering. So speaking of which, all right, does it look like my computer is gonna, that's interesting. My computer seems to have decided to lock up here for a second. Never had that happen before.
Dennis, why don't we have Austin go, and that'll give you some time to get restarted.
Yeah, sure.
Okay, so if you just want to stop share your screen, and then Austin, you are up.
Yeah, and I'm actually attempting to do that. And believe it or not, things seem to have locked up now. My computer won't even, cursor won't even move. I don't know if you as moderator can shut me off.
Are you able to see my slides now?
Yes.
Okay, great. All right, Dennis. All right, so picking up where Dennis left off, actually the message he was sending fits pretty well with my experience. I work at a company called Emerging Technologies. We're located in Two Rivers. And tell you a little bit about myself. I'm from Manitowoc, but lived here my whole life except for a short stint after college. I went to Lincoln High School. From there, I went to Michigan Technological University, and I pursued a bachelor's degree in chemical engineering. And I chose chemical engineering because it was the most interesting to me At the time in high school, when I was ready to graduate, I loved chemistry and decided to do chemical engineering. When I graduated, I did nothing with chemical engineering. I went into operations engineering for a couple different companies and am now an engineering manager for a company that does electrical engineering. So what Dennis was saying right at the end there is exactly right. If you learn the fundamentals of engineering, there's really no limit to where you can go. So what's really cool about engineering school is you get the opportunity to have professional experience while you're in school. So the first couple of years that I was in college learning to be an engineer, I got a chance to work for some big companies as an intern. And so I worked at Kimberly-Clark in Neenah, Wisconsin, doing a process engineering role there, where my job was to help keep the manufacturing lines moving. I worked at an oil refinery in Minneapolis, Minnesota, where I was an operations engineer helping keep my process unit running, producing oil and gas for the consumer markets. And from there, when I graduated, I was recruited from Michigan Tech to go work at Polaris Industries and pursue my passion in power sports, things like snowmobiles and four-wheelers, where I got to be an operations engineer, working on a variety of projects over the last 7 years to produce the best vehicles in the world. And then from there, I decided to come home. My family is here. My wife and kids, we wanted to move home and be closer to home. And consequently, Emerging Technologies also needed a engineering manager. So I was able to come and take the next progression in my path in engineering to now lead a team of engineers, and like me, who are younger and developing in their career. I chose Michigan Tech because at the time, their chemical engineering program was one of the best in the country. And even more important than that, they have a really strong career development program, and they have a good career fair, a lot like this, where companies come to recruit college grads. And so it made it really easy for me to have a career coming right out of college. I was recruited to go work at Polaris and pursue my passion for engineering. For me to choose to be an engineer, I knew pretty much my whole life that I wanted to be an engineer. My dad's an engineer, and my hobbies outside of school and work promote that. I like to work on cars and trucks and motorcycles, and being able to do that and get paid for it was why I wanted to be an engineer. So I went on to engineering school right away, and I always knew that that's what I wanted to do. And if your interests are aligned with working on anything, that might be a good path for you. I started in junior high, taking all of the shop classes that were available, and then at Lincoln, taking the engineering courses that were available there. And that was all good prep work to go into college. And in fact, there was an engineering class I took at Lincoln that earned me college credit at Michigan Tech. It was a transfer credit, so it was a good deal there. So a little bit about Emerging Technologies. We're a local business here. My dad founded it back in 1999. We've been located in Manitowoc, Two Rivers area for the last 22 years. We are currently in Two Rivers. We've expanded to a 10,000 square foot facility where we now produce test equipment for some of the largest manufacturers in the world. We have equipment that's all over the world. So we work here in Manitowoc, Two Rivers area, and we send equipment everywhere in the world. We've got a lot here in the United States, but we have equipment in China and Puerto Rico, Mexico, Brazil, so all over the place. Really, wherever there's a manufacturing need, there's a need for test systems. And so a test system, what we build here in Emerging Technologies is an automated machine where our customers can put their product in, they load it into our machine tests their product to make sure that it works properly. And so when you're developing new products, usually you have a specification where you decide how that product is supposed to work. And then it has to be tested once it's been built the first time to make sure that it works right. And so we serve the development market that way. We build testers that go in lab environments for the development engineers to test their products to make sure that they're working the way they expected them to, and that they work long enough and that the products live long enough to be useful to their customer. We also do testing on production lines so that as products are built every day, at the end of the production line, they can be tested for a quality check to make sure that they work the way they're supposed to before they arrive at the customer. So that's a little bit about what we do. The company as a whole, it's a family-oriented business. We really invite young talent to come in, learn, and grow with us. We employ engineers, we employ assembly technicians, we employ admin assistants and secretaries, and pretty much at every level, we have people in our business to help keep everything moving. So the engineering team is responsible for designing the parts and systems. The manufacturing team builds those, and then our field service teams can deploy those systems out at the customer site and then service them for the life that they've been installed. Every day is a new challenge for us here. We do everything custom, meaning that every project is different. We don't build the same thing every day, all day. Every project is something new. And we work with some of the best customers in the world. We work with huge companies that have a global presence with manufacturing all over the world. We also work with local partners that are just down the street from us. So we have the opportunity to learn from and work with the best. Being a small business, we're a very flexible environment. And so we allow our employees to have a much more flexible schedule. We typically, on the engineering team, we work somewhere between 7 and 5. For a work day, it's usually 8 to 10 hours, depending on what's going on. We work more when there's more going on, and we work less when there's a little less, and we can take a little more breaks. The manufacturing team has a more rigid work schedule. They usually work from 7 o'clock in the morning until 4 p.m. every day, and they're working every day to build our systems and get those deployed for our customers. We offer all the same benefits as big companies. We offer paid time off, and we offer health insurance and all those things. But the main thing, what we do every day is we develop test systems from concept through deployment. So that's everything from the idea of how it will work to actually getting those deployed at the customer site. Some of the things that we actually do, so you can see what it looks like, we have to do the 3D design and modeling for the systems. And so we have to actually design how to hold the parts. Whatever the thing is that we're testing, we need a way to hold it and connect to it. And so we have 3D designers and mechanical designers on staff that take care of doing all of the drafting work to design those systems and fixtures. And then on the electrical side, we build electrical panels. Everything we do is automated control, meaning that we have computers that control the movement and the testing that's happening inside of our systems. And so we have electrical engineers here that design the electrical systems. They pick all of the parts. They design all the wiring schematics. Then our manufacturing team can build those systems based on the design documents produced by our engineering team. And then lastly is the software to control it all. So I mentioned that the systems are controlled by computers. And so we have our own custom software that controls the system, controls all of the movement, controls all of the instruments, all of the data we collect, and then it presents that to the user on the screen on a PC. And so we hire software developers as well. And so we do everything, the system complete from start to finish. We employ lots of different types of engineers. We have mechanical engineers, electrical engineers, software engineers, manufacturing engineers, all in engineering. Plus we have the assembly technicians that are out doing the work, turning the wrenches, putting things together. And then we have the field service crew that goes out and services the equipment while it's in the field. So the industries that we serve, almost all industries that produce a product require some testing at some level. And so we serve a lot of electrical and electronics industries. And so there's some pictures of power grid type components that our customers make those. And that's kind of been a sweet spot for us. It's a market that there's not a lot of other people in the world that know how to work on equipment that generates upwards of 100,000 volts of electricity. We get to work on some really interesting things like simulating lightning strikes. We get to do really high current testing for those products. And so that's really interesting. It's a very special market that we're in. And we don't, we are some of the few people in the world that know how to work with that level of electricity to test those kinds of products. But in addition to that, we do lots of other industries. If you've flown on a modern jetliner, there are parts in that airplane that were tested with our equipment. So we serve the aerospace and defense sector. We also do boats and trains and cars, and we test parts for almost every market. We work with some of the biggest OEMs, which is the original equipment manufacturers in the world that produce parts that go on your cars. And we've gotten to do some really fun defense projects where we work with defense contractors and get to be a part of military style projects too. So really for us, there is no limit to the markets that we can serve. We're out every day finding new technologies to be a part of. And that's one of the best things about working here is getting to work on new technologies where we get our name. We look to serve the emerging technologies in the market and help assist in testing product to verify that it's good to hit market, and then test products while they're being built to make sure that they're good quality for the customers. This is a few images of what it looks like when that comes alive. We keep a pretty good presence on LinkedIn, social media. We post all the time, but this is sort of the variety of things that we work on. So we design and build little circuit boards. We also test little circuit boards. We do the panel wiring. We've got 3D printers here running, making parts all the time. We do the 3D modeling and design, and then actually build those parts. So it's really cool because you get to see those projects from start to finish. You get to be the designer that comes up with the design, and then you get to help put it together. We have our software engineers that mostly sit at the desk and do the software development. We do big safety cages. So we do equipment big and small. So the yellow safety cage in the lower right corner is a design that's ours, and that high voltage testing happens inside of those to keep everybody safe. So it's really a variety of things that we get to work on. It's a lot of fun. And this is the last slide that I have, talking a little bit about emerging technologies. So I can pause there for any questions.
Great. Thanks, Austin. I'm actually going to turn it back over to Dennis so he can finish up, and then we'll have a couple minutes at the end for questions as well. So Dennis, you will have about 6 minutes. And actually, it looks like we lost Dennis. So I will open up the floor here to Austin for questions. So questions for Austin. And I will mention as well that I failed to introduce myself at the beginning, but I'm Carrie Miller, the Manitowoc County Youth Apprenticeship Coordinator, and I also do Inspire for Manitowoc County. So for the students listening, we do have some opportunities in the STEM area for youth apprenticeship, including engineering. So if you are interested in that, take a moment, go see your counselor, learn a little bit more. I am in the schools. Bonnie Perzeniak is at Lincoln High School. And then we have Lisa Klein at Two Rivers and Julie Noss at Manitowoc Lutheran. So I'm in the rest of the schools. And then we can connect and get you connected to some opportunities through either Inspire or Youth Apprenticeship. All right, so question came in. What do you like best about your job, and what does a typical day look like for you, Austin?
So a typical day for me starts with a morning production meeting where we gather the team and talk about what we did yesterday and what we need to do for the day. And from there, we kick the team off, they go to work. And so those guys are out doing the design and build of the systems. And then I'm managing reviews of all of their work. So I'm reviewing drawings, I review the build, and we do the testing. We actually test the systems here. And so I bounce back and forth between projects all day long. I sit at my desk for the most part, but I do walk around out in the shop to review the projects as they've been done. And so as the manager, I'm doing a lot of approval work to make sure the team has the guidance they need, that the designs are getting done according to our requirements. And then at the end of the day, we usually round that off with a short review of the work that we completed and get ready to go home. And so what I like best about my job is the variety. We work on anywhere from 10 to 12 projects at a time, and they're always all different. And we do about 30 to 50 projects in a year. And so it's the variety that we get to see all of the different industries that we work on. So for me, it really is the variety of tough problems to solve. So being an engineer, we basically get paid to solve problems. And so having a variety of those to work on is always a good day. So typical entry-level wages was the next question. So the assembly technicians, we come in, they get paid based on their experience level. So it's everything from about $15 an hour and up based on their experience, and they're paid hourly. On the professional side, so in the engineering office, that is changing, and it's been changing with the market here, but we are competitive at the entry-level salaries. So we're typically in a range of 45 to 60,000 a year based on experience for an entry-level engineer.
Great. Is there anything you dislike about your job?
Well, being engineering, having tough problems to solve, it can be a little stressful at times. And so sometimes having customers that don't always understand how their product is supposed to work, or having something so complex that we need to learn new skills here can be stressful, and it can cause us to have to work a little extra. And so that's probably the toughest part about my job. But as far as things that I don't like, there's very few of them. I've been in engineering for a handful of years now, and I continue to do it because I really enjoy having these problems to solve. So I see the next question is, what do I recommend a high school student do if they're interested in engineering to prepare themselves? Well, what it worked really well for me was taking advantage of the engineering classes offered at the high school. At the time, Derek Fallon was the teacher that I had in the engineering department, and he was a great mentor, and he really let me do as much as I was willing. I did some independent studies, and so take advantage of those, make the most of them. When you're doing 3D modeling at the high school level and you're learning how to use Autodesk Inventor, pick something hard to model, don't just skate through. And then I took part in the college prep track at the UW Extension. So I was taking college classes when I was a senior in high school. For me, that was a big jump start because it was real college credit. When I got to Michigan Tech, I had almost a year's worth of college credits in and got to start at year 2 as an engineering student. And so if you're looking for the quickest way to get to a good paying job as an engineer, there's ways to make the most of those programs to earn college credit. So is there any additional schooling that you must do to get into the field? That answer is no. So here we hire people with no schooling and no experience on the assembly side. So someone who's good working with their hands, that's a good hard worker with a good positive attitude, we'll bring those people in all the time. On the engineering side, if you want to go into engineering, the best thing to do is complete a 4-year degree. There's different levels of 4-year degrees. So there's some that are less rigorous that are called engineering technology. And so those are still 4 years, but they're more focused on hands-on. It's more like what technical school used to mean, where you get hands-on experience more in lab. It doesn't require calculus. It's kind of one of the big divisions there. If you're going to be an engineer and earn an engineering degree, you're going to do a lot of complex math, high-level calculus and beyond. And so if you're going to get a full-on engineering degree, that's going to be required. But there's lots of engineering degrees. After your 4 years in college, there's all kinds of jobs you can get. There is opportunity to do more schooling. So if you want to specialize, if you want to learn more specifically about oil refining, or you want to learn more specifically about engines, there's master's degrees and PhDs that you can get to become a development specialist at different companies. So difference between 2 and 4-year degrees. So from my experience, practically the difference is the level of theory. So 2-year degrees are going to be really focused on hands-on, giving you the skills you need to go into a job and immediately get to work. And so typically the way we use resources that have a 2-year degree is they get more direction from an engineer. They do use the tools to do what they're told by the engineering team to accomplish the goal. Then if you go out from the 2 years into the full 4-year engineering degree, those engineers are the ones that are deciding what needs to be done, how things get done, and give the direction to the less skilled resources. We need both. So one of the challenges that we've had is that when you go through engineering school, you become the engineer, you want to be the person who is making the decisions and who is deciding direction, how things get done. A lot of times you don't want to waste your time doing drawings and doing the drafting. And so we like to bring in people with a 2-year degree to do things like drafting and design work at the direction of an engineering team who has all of the training in theory and how and why things work. Job outlook for engineers. Are they needed locally? They absolutely are needed locally. We, as for example, are in desperate need of local engineers. We are always looking for engineers that want to be in the Manitowoc Two Rivers area. And when you go, most students have to go away to go to engineering school. There are some more local programs starting now. You can get an engineering degree through Green Bay. I traveled 8 hours away to go to a school out of state. And most students who are willing to do that are willing to go wherever they can get the best job. And a lot of times that takes them to big cities. And so it's a great opportunity if what you want to do is relocate and move to a big city. I lived in Minneapolis for about 5 years. We loved it there. But in the end, we wanted to come home because this is home for us. So in general, the world needs engineers. Dennis hit on it. We don't develop new products. We don't solve the world's problems without engineers. And there will always be needed. And then locally, we have industry here, and industry requires engineers. So anyone who who's building anything, manufacturing in the area, they need engineers to keep their manufacturing lines running. We're developing technology here at our facility. We need engineers to support that. So it is a great field to get into with a good job outlook and plenty of job security.
Awesome. Thank you so much for all the information, Austin, and taking over when we had some technology difficulties. So we really appreciate your input today. And I don't see any other questions. So we are actually at our time. So thank you so much for your time today. For all the students, thank you for listening in. Hope you guys have a wonderful day.
Thanks, everyone.